your time. I was hoping Mike Fitzgerald would join us. I'm going to share my screen. On the right. Okay, so we're here to share, what we've been working on in terms of the LGAO Future Study Group. Anybody sees Mike join us, so let me know, please. There's a number of members of the Future Study Group with us right now, but the agenda Mike and I were thinking of was to basically go over the charter for the FSG and the membership, so you know who is participating in this group, and then the goals for today. Talk about the recommendations that we've been sharing with the SSC, then have some open discussion about that and see if other people have additional ideas. And then we wanted to spend the last quarter of the session basically talking about what we have in mind for the strategic planning workshops in October, and get your input on that area. So this is basically the charter that the SSC gave the FSG. So it basically came from a white paper that we submitted 2 or 3 years ago, and they endorsed the concept of the improvements and recommended that the LGAO working group be reconstituted to prioritize possible activities and establish science linkages, and then before considering for significant funding. And so we did that last year. We did this, in 2020 and in 2021. We'll talk more about the more recent ones in this session. And the members of this group all the names are here, and a number of those people are on this call. So I hope you folks help me in terms of discussing what the FSG has been working on. And please interrupt anytime here, because this is intended to be a combination informing, but also getting your input and thoughts. So at the most recent July SSC meeting, we made a number of recommendations, and those recommendations fell in the category of a project called ORCA, which is a higher order deformal mirror, in efficiency and stability, the adaptive secondary mirror we've been working on with Phil Hims and company, PostDawn Observing, a project called ORCAs, and then next step studies. And so in these following slides, we'll review those findings and recommendations. And again, we're looking for thoughts and inputs here.
Peter, can you hear me?
Yes, I can, but you're very echoey.
Try again.
Peter, is this better?
Yeah. So Mike?
Yes, I'm here.
Okay, why don't you take it from here, Mike?
Okay, and just briefly to recap, because we had a little trouble connecting in the room here for folks. First off, we're going to review the recommendations that the committee made to the SSC in the July meeting. And we'll go through those. Peter and I tag team that pretty quickly. We'll break a little bit for an opportunity to discuss and get some clarification or feedback. And then we'll come back and start talking about strategic planning exercises in the future. Okay, so this slide here is the first recommendation that came out of the FSG for the July meeting. This is for the high order all sky adaptive optics, and especially for the students and newcomers in the group, this is an acronym soup area. So if there is any clarification needed, please feel free to pop in and ask for clarification. So HACA was an MRI, was submitted to the NSF Major Research Infrastructure Program in January. Unfortunately, it was not successful, but the committee has reaffirmed the importance of it, strategic importance, and for 2 reasons. So first off, the high order DM, higher deformal mirror from this project would enable improved performance, both in natural guide star and laser guide star. You can see on the right-hand side the top plot here shows is there a laser here? Performance with HOCA for adding in the deformal mirror relative to current performance. So this coarsely dotted line here is when you add the deformal mirror. Higher order, better fitting error, so improved spell. And additionally, if we add in the infrared pyramid wavefront sensor as part of this, we get improved laser guide star performance here and improved coverage. This is where the all sky Keck adaptive optics recommendation comes in. This also importantly leverages investments in the real-time controller that have been ongoing. And so this really does synthesize a lot of the ongoing efforts at Keck and really bring it to a new level of performance. It would enable longer term operation of adaptive optics in the visible. So it is a very powerful upgrade to the system. And so the recommendation is that we continue to try to pursue this project. FSG is going to assist in preparing a resubmission for this proposal.
Might just add the top plot, the very top curve is basically advanced wavefront control techniques that are, basically allowed by the new real-time controller and the higher order on the deformal mirror.
Thanks, Peter. And I should add, there are many FSG members both in the room and in Zoom land. And if anyone wants to pop in and add clarification, please feel free to do so. Next slide. Another important recommendation was to continue investment in efficiency and stability of the adaptive optics system. One of the outcomes of this is that the recommendations of the FSG have gone into these operations plan for fiscal year 22 for the observatory. So that means it will be part of the internal investment of the observatory to improve the stages, the controllers, all the bits and pieces of the AO system to make them more efficient, more stable, improve documentation that will provide a better basis for the future. And so we are happy that this has been incorporated into the observatory plan. We're going to continue to support this, and it remains really important to maintain both efficient and stable systems, and it provides a real basis for improvement in the future. And finally, the last slide I'll talk about before handing over to Peter for some additional points is the adaptive secondary mirror. This has been a topic discussed over many years, but really this is coming out of a renewed effort by Phil Hinch at UC Santa Cruz, building on a new technology for adaptive secondary mirrors from a company in the Netherlands, TMO. This is a new type of actuator technology that will enable lower power operation and allow you to get potentially reduced cost for an adaptive secondary mirror. The FSG has found that really this is going to be a great service for GLAO-enabled science. There are benefits for lower thermal background, but really the biggest driver seems to be GLAO. And so this would help enhance seeing modes for instruments behind the ASM. And so we want to continue supporting the technical study of this technology and what instruments are best suited to benefit from GLAO. Each instrument would need its own wavefront sensing in order to take advantage of this that adaptive secondary. And so the recommendation is that the FSG members continue to support the study of the ASM, in particular GLAO applications. And we recognize that on the FSG, we don't have as much of the science breadth for the GLAO-enabled science. And so we recommend that we recruit some additional membership to support the study of GLAO science enabled by the adaptive secondary. But I do think that this is an opportunity for additional membership. If you're interested, of course, talk to Peter or myself or any of the other FSG members. All right, Peter.
Yeah, so an area we worked on the year before this past one, but then we sort of put on hold for a bit, was PostDawn Observing. The idea is that right after, as you can see in the top right plot, right after sunset, the seeing is actually, sorry, sunrise, the seeing is actually still pretty good for 2, maybe even 3 hours. And so if you could actually somehow observe during that time, as many solar system astronomers may do already, you could add a lot more both science time and engineering time. And what allows us to potentially do this is, first of all, we've got a bright laser. So, and we can reject, we think we have ways to reject the skylight in terms of the wavefront sensing. And then also in the near infrared, where we now have wavefront sensors as well for low order correction, the sky is fainter even after dawn. So we've got a number of science cases that we think would really be facilitated by this. Plus, it would be a great time to do engineering instead of, the darker time that could be used for science. So FSG is basically saying that remains an attractive capability for increasing both science and operational time, but it needs more investigation. We did investigate another number of the aspects, but we really need to think about the further impacts on the observatory of running, an extra 2 or 3 hours each night, because it could be potentially, a couple hours every night on both telescopes, that we switch over. And so we do need to make some resources available. We've got a lot of things already going on. But so if you want to help us on this one, think through the issues, that'd be very welcome. ORCA's is a new project, which is being led out of Goddard. And basically the idea is ORCA stands for Orbiting Configurable Artificial Star. And the idea is to have a laser source, 2 wavelengths, on a spacecraft that's at a high altitude orbit, and therefore you get a point source. Also, it could provide calibration sources. And the idea is to put it next to your science target, and it can be there for up to a few hours at a time. The frequency may be, for specific targets, may be low in terms of every 4 nights or something, but there's also intermediate targets you could be observing for surveys. And so a pretty extensive report went into, on the spacecraft side, on the AO side, went into Goddard management. They basically approved it for submittal. We'll be submitting a bigger proposal due December 9th to NASA. And the idea here is, on the AO side, is this is an opportunity for us to push the AO systems into the visible. If you've got a bright source, I'm talking about something like 0th magnitude, photons for your wavefront sensing is not an issue. So you could have much higher order correction, much faster correction, but we also need to upgrade the AO system in order to take advantage of that. And we also need to have visible science instrumentation to take advantage of that. And so this is an opportunity to upgrade our AO systems, not just for ORCAs, but for general science, because a lot of the capabilities will be needed for many different cases.
So Peter, do you want us to hold our questions to the end, or can we ask about this?
Go ahead and ask a question, Andrew.
Okay, so help me understand this. This one I have never fully appreciated the enthusiasm for this, because it seems hard to get a satellite around efficiently enough to really have high science impact. So what is it that makes this so attractive?
Well, what makes this attractive is that for, in say a 3 or 4 year mission, you can observe 100 targets, at a very high performance level.
And it's high performance because you have such a bright source compared to what what you can create with the sodium.
Right, and it doesn't have any of the issues of the sodium laser, right? Because it's a natural guide star. It provides you with, all the information. You don't need a separate source to tilt, for example.
So how high is the satellite? What's the
something like 180 kilometers, I believe. It's basically a point source, and it basically can be within 10 arc seconds or so of your target for,
That's twice as high as the
It's,
laser.
it's like
Right?
200,000 kilometers,
sorry, 200, thank you for the correction, Carl.
like up near the moon.
Okay,
Yeah.
200,000 kilometers. Okay, so that's a big difference in altitude.
Yeah.
Okay.
But doesn't have any cone effect, for example.
Yeah,
But that's just because of the 90 versus 200,
Yeah, it's-
right?
and it has none of the sodium issues, you know, that it's moving and structures changing, that kind of thing. Or none of the requirements in terms of, you know, aircraft or space command, right?
So, I mean, again, back to just basic argument, it's the ratio, the cone effect goes as the ratio of the height, right?
Well, this is essentially like a real star.
There's no cone effect.
No cone effect.
How can there be no cone effect?
Well, it's far enough away to basically be diffraction limited source at a high altitude.
Isn't it basically twice as high? It's a factor of
No.
2 higher, right?
Carl just corrected me, right? 200,000 kilometers, not 90 kilometers.
Oh, right, sorry, my bad, okay. Okay, now I get it. And then it's bright.
It's bright and it provides all the information you need. And you
So
can
how
locate it.
much brighter is it compared to, say, the laser?
Well, the lasers, well, it depends how we break it up, but the lasers, you know, 8th, 9th magnitude, and we're talking about 0th
Okay, great.
magnitude.
And you can put it exactly where you want.
Well, I just, not at the cadence that an observer might want it, right?
That's right.
That's part of the mission trace day. There's a whole document on this, but yeah, it does work.
I mean, if the Galactic Center, for example, was the key target, they could put it there time after time. Right, but you know, we got to judge which targets it's going to be used for, right? There's multiple science cases being. So the idea would be you'd already know largely your targets for the next 3 years, ideally, so that they could have the most efficient use of fuel on the spacecraft.
And you can do the, I mean, it seems non-trivial to line this up from, or my,
It's non-trivial for you and me, but the guys at Goddard do this all the time in terms of determining.
What's the size of the spacecraft? What class spacecraft is it?
I think it's, well, the original idea was to have something on the, I think it's a 10U kind of scale, but they may have a free one that's at the 6U scale. So we're looking at things.
Is pointing stability of your light source an issue? I know with the smaller ones,
It's a critical issue, but we believe that we can control it certainly better than 5 milliarc-second level. And then we can also track it with our AO system to try to make compensating offsets. So we've been looking into that stability issue because it's our pointing correction as well, right?
yeah.
It's like an 80 kilogram spacecraft, about a meter in size. There's supposed to be 4 of them.
Okay, well, we can have more questions on this topic and discussion. I'll just do the last one I was going to do here before going to open discussion or more general discussion. The next thing is just that the FSG is also starting to look at laying the groundwork for future proposals. You know, for example, what would be the next step for K1AO after COPPA? You know, what do we do once we have and that might be a higher order DM or whatever's next, right? And their implications. And then one of the other recommendations associated with this, but also associated with HAWK and ORCA is to actually implement a visible science camera in the short term for Tech2AO. And actually Goddard is going to provide some labor and has provided some funding to support this. And Max Miller-Blanchard is going to be the project scientist for that. I'm the lead on the technical side. But what we're basically going to do is next to the acquisition camera, as you see in this bottom right image, put a fast CMOS detector that can read out at, hundreds or 500 hertz or something like that, and have a small corrected field and basically do lucky imaging, right? And this would be a precursor basically to an effort that Max is leading to talk about, to determine what the appropriate future visible instrumentation is. And then from the ORCA's perspective, it's to, do a technical demonstrator of how we can do AO in the visible. And from the HOCA perspective, we said that, once we have the higher order DM, we really need a visible, at least a scoring camera. So it's going to serve all those needs. So we can talk about any of these items now for a while. So just people raise questions or thoughts or suggestions.
Hi, Peter, what's the timeline for something like HACA?
HOCA is a 4-year project once we get it funded, Carl.
So is there R&D involved to develop that DM?
No, the formal mirror, the one we're thinking of, which is an ALP-AO DM, has been already being fabricated and it's being demonstrated, for example, for the VLT. So people are already using it. It's going from a 7mm actuator spacing to a 2.5mm actuator spacing.
Since why does it take 4 years?
That's to do all the things on the wavefront sensing side as well, right? I mean, we have to upgrade the order of the Shack-Hartman and the pyramid wavefront sensors. And it takes, Sam's the PI on this. I think it takes almost 1.5 years just to get the DM.
Correct.
Tuan, you had something?
Yeah, I have a question about the LGAO. So I thought Jessica led a team to study the LGAO possibility. So how does that, connect with what you guys are thinking about LGAO?
Are you talking about, what do you mean?
GLAO, sorry. The GLAO
GLAO.
working group. Like there was,
Thank you.
Jessica led like this GLAO
Yes.
group, right?
Yeah,
And then you're saying like you want to constitute a new group, like, or
Well-
like how does this group and the other group?
Yeah, let me give you a little bit background. So, basically that effort led by Jessica, Mark Chan and others wrapped up in 2018 with an SPIE paper. And then basically there wasn't enough energy within that group at that time to go further. And then Phil Hims joined Santa Cruz. And, this is a big interest of his. And that sparked us restarting basically. Phil, do you want to add something here? Are you in the call?
Well, yeah, just to say that it's not a different group. It's Jessica and Mark are still involved, and that was sort of the what's possible side, and now we're looking on the technical implementation side at the moment.
For those who aren't all that plugged in, Mark Shun and Jessica built a GLAO system for one of the UH telescopes, which worked quite well in the meantime. And Mark is installing one of these, a very small version of one of these new technology adaptive secondary mirrors on another UH telescope this summer. What are they, or this fall? January, February. Okay. So there has been a lot going on. It's just, it's been in the context of actually doing the experiments and verifying that it's quite interesting. And in the meantime, also the VLT has installed one of the Italian origin adaptive secondaries on one of their unit telescopes, and they're getting very good results. So I think there's been a lot going on. It's just that we've been looking at a different aspect of it. And my own feeling is this is a good time to pick it up again.
The other aspect, hopefully everybody can hear me online. The other aspect is that when we did that original study, we were looking at existing instruments and whether they were capable of being used with the GLAO system. And there were sort of limitations for each existing instrument. But now we have new instrument concepts coming along, like Phobos, or we can look at HWI, or we were thinking about adding on or modifying the existing system. So there's just a natural evolution with the technology on the secondary side, and the instruments is getting better and now ready for dealing with that.
Ben, you have your hand up?
Yeah, I don't know if Phil may have brought this up in previous meetings, but since it wasn't in the slide, it's the adaptive secondary is actually potentially pretty advantageous for high contrast imaging as well. When you combine that with a deformable mirror like ORCA or any other one, you can make a full dark hole as whereas with one you can only make a half dark hole. So it's like it makes it like the space telescope missions with deformable mirrors that have two of them. So that is not just a wide field benefit.
Right. We have talked about the advantage of more separately controlled actuators to suppress speckles, things like that. But I don't think we actually thought of the full dark hole aspect.
It's specifically because it's out of the pupil plane. So one, the second adaptive secondary, whereas the other DM would be in the pupil plane. So that it's just naturally set up to enable that.
It's
It
not
would be great to
terribly-
model this because it's not all.
Yeah, we don't know for sure.
Sorry, Peter.
Thanks for that suggestion, Ben.
We have a question in our room. Mr. King.
That's actually going to be Katrie's another topic and ask a clear question. It's framed as what's your strategic vision for more laser power?
Can you repeat the question, Mike?
What's the strategic vision for more laser power?
Oh, well, it's not, well, sorry, I don't know that we have a strategic vision, but on KEC2 initially we put in a platform that would allow us to put 2 more Toptica lasers in. On KEC1, we haven't done that for COPPA, but Toptica, or a combination of Toptica and MPB in Montreal, are actually working on are working on a higher power version. And also Domenico Bonaccini, I think, recently demonstrated something like a 70 watt versus our current 20 watt version. So there's possibilities of upgrades for sure.
Yeah, thanks, Gary. I think strategically, you want to think of factors of 5 or 10 or 20 laser power. Because as you know, the scaling laws, the lower wavefront error require laser power graciously. One thing that I wanted to bring to our consciousness, we're building an ultraviolet Rayleigh laser system at Palomar. And we've been looking at the cost per watt from 355 to triple gag pulse laser light. It's fallen by almost a factor of 10 compared to when we built the RoboAF system. We seem to have Chinese manufacturers that can deliver appropriate pulse formats for about $1,000 a watt. And so we can imagine, hundreds of watts of laser power. And so it kind of opens new potentials. We're thinking of John's Tech 2035 vision.
I'm not sure I got all that, but that's Rich, right?
Yeah.
But it's definitely worth discussion for 2035 is, when do we need more laser power? How would we use it? I mean, for example, going to MCAO or something like that. It's not, of course, laser power right now, today isn't our limitation, but we have to deal with other things first, but it will become our limitation again at some point, especially if we go to higher order DMs and focal isoplanetas.
Well,
But-
Peter, we want to run faster. And at some point, laser power will become the limitation for that.
That's true. Yeah, either with more speed or probably sooner than that, it'll be more actuators. You know. So I didn't get all your thoughts, Rich, but I'd love to hear them separately, maybe.
Sure, yeah. You can trade laser power off against a lot of other technological limitations. So I think you always want that.
Other thoughts, folks? Maybe since Rich kind of led us in this direction, we might want to talk about strategic planning, take some time now. I'm not sure how we're doing on time overall, but
I think this is about when we wanted to transition
Yeah.
to the strategic planning discussion.
yeah, and you'll take over here, Mike, but I mean, this follows on John O'Mara's comment about, KEC in 2035. We want to be thinking about KEC-AO in 2035. So go ahead, Mike.
Right. Following on, inspired by the fact that we need to be undertaking strategic planning exercises, the AO FSG has kicked off some efforts, and we've planned a few workshops independent of the Master 2020 results. I do have blocked up here on the slide here a little QR code. So if you're interested in signing up for one or all of these workshops, please feel free to follow that link. We have 3 workshops planned for October, and the topics are enhanced seeing limited science. So this is following on the GLAO and ASM discussion, looking at wider fields. Phil Hintz and Mark Chun are organizing that. That will be October 13th. The next session is the exoplanet high contrast science. This includes it's very exoplanet focused, but also includes non-exoplanet high contrast science. Myself, Becky Jensen-Klim, Mike Liu, Dimitri, and Sam Ragland are organizing that. That's October 15th. And then finally, the third workshop is the OIR universe at high angular resolution. And so this is all the other science that you want to do with diffraction limited AO. And so Chris Fosnacht, Jessica, Catherine DeClaire, Peter are organizing that. That'll be October 18th. Registration signups are open, so please feel free. Follow the link on the QR code. We've sent emails around about that. We'll send another email again. And if you're curious, please contact myself or Peter. Here's where things stand so far in terms of people registered. So we've got a pretty good balance amongst the 3 workshops. So I believe we'll have lively discussions no matter what. And we have a fairly broad range of science interests amongst the folks attending. So it should be good discussions. If there's anything else to say, Peter, next slide. Okay, so we have opportunity to have a little bit of discussion and input from people about what we'd like to see out of strategic planning exercises. And then in a few minutes, we'll transition. We have a slide apiece from each of the organizers from the 3 workshops that we can go over. So I'll stop here and really see the discussion with the point of these strategic planning exercises to really get a vision for where we want them to be in 2035. What sorts of developments we want to see along the way in order to get to that point. These strategic planning exercises, I expect will go into the broader strategic planning effort of the observatory undertaken by John and SSC. And so as we learn more about that process, that'll be where these inputs, the outputs of these workshops go.
What I know of the other process is it's likely the SSC will have their strategic planning meeting in the early December timeframe. And so, we'll have a chance to consolidate our materials and share it with the SSC. Claire?
There's an odd dissonance in the timescales for this because, which isn't to say we shouldn't go ahead with this, we should. But in the near future, we're going to have JWST, which will not have diffraction limited imaging below, I don't know, 1 to 2 microns, depending on wavelengths, depending on who you believe at this point. So there was an opportunity for us to get going in the visible, at least in the red part of the visible, and be able to play the same complementary role with JW as we've played with Hubble, except in Hubble did the short wavelength and we did the long wavelength. And with JW, there's an opportunity to flip it and turn it around. But I don't think all is lost. If we can really push on HACA and get it going in 3 years, and hopefully JW will still be there in 3 years, we can play that role. There were tons and tons of papers written with IR results from KEC and optical results from Hubble. We could do the same thing, except in reverse. So that sort of raises the urgency of HACA for me anyway, as I think about it.
I agree with you, Claire, and other people have pointed that out as well. So a question is how we do accelerate our time frame.
Yeah.
And also, you know, of course, the recent Hubble troubles have inspired people to be thinking more about this.
Peter, there was a request to put up the slide with the QR code again. If you could advance backwards. And there's a question in the audience. Jessica has her hand up.
Yeah, I was just gonna say, the OIR universe behind the resolution, one of the things I'm most excited about is this MCAO system that lets us push into the optical, also increases the field of view and the infrared as well. But exactly that, as a Hubble replacement or a complement to JWST, it seems like the next place to go with the laser guide arrays.
Mike, I'm not sure if we're using the right microphone there because I personally have some trouble hearing the people there.
They're both on green, maybe.
Okay, can you hear me now, Peter?
That's better.
Okay, so I was just saying at the OIR universe and angular resolution, we'll definitely talk about Claire's point, and that HACA might not be good enough. The next logical step for laser guide star AO really does seem like an MCAO system that gives us optical capabilities and a larger field of view, both in the optical and the infrared, to replace Hubble or to complement data. Did that come through better?
Yes.
And just along a similar line, Jessica has tomorrow leading a breakout session on post-HST optical stuff, which I think will also include high contrast visible or just general NGS visible science. So it would be great to have people on there as well. That'll be more of a focus on science.
So, I mean, some people may not have quite got that, but I'm just going to repeat what I think I already know, which is there's a breakout session tomorrow that Jessica and Max are leading on visible instrumentation. And as Max just said, it focuses on science. And that's a point we should make for these strategic planning sessions in general. Our goal is not to think necessarily about how we get there, but to think about, you know, what role you want AO to be playing in your science by 2035. Because then subsequently we can think about how we, you know, our tactical solutions to getting there, but we want to understand first where we need to be. So we should be thinking from the science perspective. Mike, should we, you know, let Jessica and the folks share their next slides since conversation seems to hesitate it for a minute?
Yeah, I think we have about 5 more minutes in the session, so that we
Is there anything, you looks like you guys have stuff in chat.
I think those are
All done already? Okay.
Bruce doing
Okay, got it.
order of magnitude.
Okay.
Okay.
Jessica, you want to speak to this slide?
You don't have the camera on? Okay, can everyone hear me online?
That's better, yeah.
Great. Okay, so for the OIR universe at high resolutions, really it's a long-term strategic planning from a science perspective. What do we want to do with tech that we can't do with other facilities in particular? During this workshop, which is just a short, not even one full day workshop, we're going to talk about science objectives that we need to achieve with high resolution optical and infrared. In all of those different domains. Most importantly, we're going to try and put together science cases that drive what we want to do with the LGAO system on the 2035 time scale. So you can see what our current template is going to be. So start thinking of ideas for your particular science cases. I think will be exciting on those time scales that we could achieve with diffraction limited or near diffraction limited imaging, all the way up into the optical and bioptical. I don't just need red, I need blue.
Thanks, Jessica. We'll maybe go through the next two slides as well. Becky, you want to speak to this one?
Sure. So this session deals with all exoplanet science that benefits from AO and all science that benefits from high contrast. So the plan is we'll have two longer discussions as part of this meeting. One will be with the full group, and I'll talk about the scientific landscape and context. So talking about other upcoming and current ground and space systems and how Keck will play a role within those new facilities. We also want to talk about new technologies that might be different from what we're currently using on Sky, for instance, interferometers, or what new technologies would serve transiting or microlensing planets in an AO context. And then we'll break up into three parallel sessions. One will be high contrast science at around lambda over D. The other will be high contrast science at several lambda over D, and then non-high contrast exoplanet science. So this is our game plan at the moment for that meeting, but we welcome your input on how we can make the best use of that time.
Thank you, Becky. And Phyllis, can you speak to this slide?
Sure. So there's a separate workshop on what we're calling enhanced seeing limited science, which is really ground layer correction by another name. That is, if you want wide fields, but some level of improved image quality performance, we'd like to gather ideas on what is driving that science. So we're envisioning a similar format to what was shown on Jessica's slide of a common session followed by parallel science sessions, where I think the groupings will be something like a session on galaxy evolution, a session on large scale structure, and then maybe, depending on whether we have enough interest, one on transients and even perhaps solar system. So feedback, and particularly on what are the right parallel science sessions, would be helpful for us as we plan this session. But the idea here is to wrap up all of those parallel ideas in how that flows down to the technical needs for the AO facility in the future. You know, what wavelength range do we anticipate driving useful fields of view, and how we satisfy that, or how we define how well the performance is on these systems.
Thank you, Phil. So I'm going to stop sharing my slides so we can see everybody. We can talk about the strategic planning. We can talk about, other ideas. So, and we have maybe 5 minutes left or something like that, Shelley?
More like 1 minute.
1 minute. We got 1 minute. Who's got their hand up? I want to encourage you folks on the line, or all the folks here, to sign up for our strategic planning workshops. We really value your input. You have additional thoughts, Mike?
No, I think that's it. We really want to have good attendance at these workshops. I think the intent is to really think big and broad. There aren't any wrong answers or bad input, and so please sign up.
And And also, feel free to talk to the organizing committees and, if you have ideas, things to add or include, or you want to help, please go ahead, or you want to help us on the FSG, let us know. So, but thank you for participating in this breakout session.
Thanks, everyone. And I think we're coming back to the main session. Shelley, is it on the same Zoom or?
No, I got it. We got a long that one off.
Okay, we're back on the different Zoom. All right, thanks, everyone.